Geometry Section 3.6, Part 2. We'll talk about standard form today. You can see I just kind of modified my Starboard software here from the previous one, so I still have the two forms from the first part 1 video, and then we've added standard form, which is the third and final form that you would need to know. And yes, you need to have all three of these memorized for the quiz that covers 3.6 and 3.7, and then again the test. And notice that I wrote standard form, and then off to the side it says with integers. Just running out of space here, so that's the short abbreviation of with integers. The reason that that is there, and the reason that these are capital letters, is to remind you that A, B, and C are integers. Okay, this B has nothing to do with this lowercase b here. These are different things. A, B, and C are numbers. They need to be integers. Reminder that what integers are would be 0, 1, 2, 3, etc. forever, and also the negatives of those numbers. So no fractions, no decimals, basically. Okay, so ax plus by equals c, that's standard form, and that then will pick up the other examples that we weren't able to do in the last video. This says use the x-intercept and y-intercept to graph 5x minus 6y equals 30. 5x minus 6y equals 30. Now, again, the method yesterday on one of the examples was to switch it over to slope-intercept form. I want to discourage you from doing that. I'd rather you do it this way. Find the x-intercept and find the y-intercept. And the way that we usually keep students honest on something like this is that on a quiz or a test is that we would make you list the x-intercept and the y-intercept. Okay, there'd be an answer blank. So here's the graph, you got to put there, and then what's the x-intercept, what's the y-intercept. And yeah, you could switch it over to a slope-intercept form, and then the y-intercept is the b, right, lowercase b. But to find the x-intercept, you'd still have to plug in 0, okay? So that right there, I just kind of gave away what we're going to do. You see the x-intercept is where the graph, the line crosses the y-axis, crosses the x-axis. That would be where the y is equal to 0. The y-intercept is where it crosses the y-axis. That is where x equals 0. So knowing that, to find the x-intercept, I'm going to plug in 0 for y. To find the y-intercept, I'm going to plug in 0 for x. Now, what happens when I plug in 0 for y? Well, all of this part of the equation would go to 0, right? 0, plug in 0 in for y. 0 times negative 6 is just 0. So now 5x is being added to 0. So then you can solve that by dividing both. So basically you have 5x equals 30. So you can solve that by dividing both sides by 5. That would be 6. Or if I plug a 0 in for x, this part of the equation disappears, right? And you're left with just negative 6y equals 0, equals 30. I'm sorry, I don't know what I'm saying today. Negative 6y equals 30, you could solve by dividing both sides by negative 6. That would give you negative 5, right? So the output then would be negative 5, okay? Now, just to be really clear about something, because I think some students always get confused by this, and they think, oh, negative 5 and 6, there's some kind of a pattern going on with these two coefficients. Not so at all. What if I made this 90, okay? Well, then you plug in 0 for x, you'd have to divide both sides by negative 6. 90 divided by negative 6 is negative 15. 0, negative 15 would be the intercept. And if I plug 0 in for y, then you've got to divide both sides by 5. 90 divided by 5 is 18. 18 comma 0 would be the intercepts. It has nothing to do with the coefficients here, except that you're using them to calculate what the intercepts are. Okay, now anyway, that's not the problem. Okay, so we're taking that off. But just keep in mind, it's a calculation that you have to do. It's not just evident in the equation. So we have two intercepts. How many points do you need to graph a line? Just 2. So you could graph the point 6, 0 and the point 0, negative 5. The amount of work they show here is ridiculous. Okay, 6, 0 and 0, negative 5. Again, wish that they would have left this for me, but you can see what we're doing. Plot those 2 points. If they're really close together, then yeah, you could kind of in a slope way kind of go, okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. There's another point. Go the other way. Down 5, right 6 would be here. And then again, please draw a nice long straight line that spans the graph, longer even than they have here. Okay, and you use a straight edge. I couldn't on a computer screen, but you please use a straight edge. All right, so with that then, if you printed the worksheet, I'd have you have that out now. And let's do number 14. If I plug in a 0, I'm not crazy about red. Plug in a 0 for x, and this would go away. I'd be left with 4y equals -4. Divide both sides by 4, you'll get -1. If I plug in a 0 for y, this would be gone. You have 2x equals -4. That would be -2. 0, -1, -2, 0. And again, these are kind of close together, so I'll just kind of recognize what the slope is now. It's down 1, right 2, down 1, right 2. That's a slope of -1/2. Okay. The slope's not evident in the equation. That's okay. Now that we've got the points in place, we can see what the slope is. It's -1/2. And draw a line. And don't forget your arrows. All right. Now, one other thing. Most math teachers will not require the ordered pair. When we ask you for the x-intercept, it's 6. When we ask for the y-intercept, it's -5. Most math teachers will see that as a number, not an ordered pair. If you give me the ordered pair, that's fine as long as it's correct. Don't get them switched. Don't say the x-intercept is 0, 6. Don't say the y-intercept is -5, 0. If you say something wrong, I take off at least a half point for that. Okay, and then we'll look at one more example. On this software, it says write equations for the horizontal line and vertical line that contains the point -7, -5. All horizontal lines are of the form y equals a number. All vertical lines are of the form x equals a number. Okay, so that being the case, and we'll graph these in just a second, y equals a number, and the point that that it contains is -7, -5. That number would be -5. So that would be y equals -5. X equals a number for the vertical line would be the x value in the point, which would be -7. So x equals -7. Now, really quickly, the graph of these, x equals -7, 1, 2, 3, 4, 5, 6, 7 to the negative would be this line right here if I'm going by ones, right? Okay, so 5 at the fifth one says I'm going by ones. Y equals -5 would be the horizontal line, like so. Now let me explain why. This is x equals -7. This is y equals -5. Why is that? Well, look at the line x equals -7. Here's the point -7, 0. Here's the point -7, 1, -7, 2, -7, 5. Up here would be -7, 10, -7, 20, -7, 100, -7, 1 million. The key character in the negative, -7, -1, -7, -2. The key characteristic there is that the x is equal to the -7. It is not the case that the y just doesn't exist. Oh, it's gone. It's not there. It's not evident in the equation. It's just not there. No, it's the case that y can just be whatever, anything, infinite numbers, all real numbers. Let y be whatever it is, x is equal to -7. The collection of the points where y is any number at all and x is -7, the collection of the ordered pairs is on this line. Okay. Similarly, let x be anything you want along this line. Y is equal to -5. So x is -7, -5, -6, -5, -5, -5, 0, -5, 1, -5, 2, -5, 10, -5. All those are ordered pairs, and the key characteristic there, the sameness there is that the y is -5. Okay. Now, why are these here? Well, I believe that these are in this section because x equals -7 is really like saying 1x plus 0y equals -7. And y equals -5 is like saying 0x plus 1y equals -5. These are both in standard form. This can't even be written in the other two forms, but actually both of these are in standard form. Okay? So then, look back at the practice sheet, looking at number 13. It says write the equation for the A, the horizontal line, and B, the vertical line that contains the given point. A, the horizontal line, is always of the form y equals, so that would be y equals this number, 2, this number, right? Whereas B, the vertical line, always of the form x equals a number, that would be x equals 0. By the way, x equals 0, I'll just use the graph in number 16 to demonstrate that. X equals 0 would be this line right here, which we call the y-axis, but it has an equation, and it is the line x equals 0. Okay? Last thing is that you should be able to convert between the three forms. So again, actually let me scroll to the top. The three forms again, 2 from yesterday, slope-intercept, point-slope form, and then today we've added in standard form. These three you must know for the quiz and the test. And we should be able to convert from one to another, in particular to convert from these two forms into standard form. Since we've already practiced going to slope-intercept form, and I really would never have you convert into point-slope form, but we should be able to convert to standard form too, okay? So we want to make these look like ax plus by equals c, remembering that a, b, and c are integers, okay? So let's do that here. Let's go ahead and distribute the 2/3. 2/3 of 6 is 4. Notice that there's kind of two things going on here. First of all, there's things in the wrong place. The x term needs to be on the other side. This -4 needs to get out of there. Also, you don't have all integers. You've got a 2/3 here. We're going to have to deal with all of that. So let's go ahead and move things first. You really could choose the order you want to do here. Let's go ahead and move things first. Let's subtract 2/3 x from both sides. That would be -2/3 x plus y minus 4 equals 4. You got to add 4 to both sides to get rid of this. So -2/3 x plus y equals 8. And then the last thing I'll do, and again, you could have done this on any of these previous steps, but usually students save this for last. The last thing we want to do is multiply through by something so that you have integers. If you don't do this, you're going to miss the point, miss a point on a 2-point problem. You want to multiply through by 3. If you multiply through by 3, that will clear this denominator, right? Because 3 divided by 3 is 1. So you want to multiply all terms by 3. And that would give you then -2x plus 3y equals 24. Basically what you're doing is multiplying both sides by 3. I model this by just saying, hey, multiply the whole equation. Really, again, what you're doing is multiplying this side by 3 and then multiplying this side by 3. You got 24 there, okay? This is in standard form. Incidentally, if you would have gotten 2x minus 3y equals -24, that is also in standard form. I believe a day is coming, whether you are in pre-calc or possibly even college algebra in a couple years from now, that your teacher will only accept this one. Okay, but for right now, as we teach you that it's got to be integers, we really will accept 2 forms of this. Okay, so either one of these are fine. The only difference between them is that I took this one and I multiplied through by -1 as well. Be like if you multiplied here by -3 instead of +3. Either of these are in standard form because they both have integers. Okay, one day you'll have a teacher, maybe, possibly, who will say the lead coefficient has to be positive. Right now, you can get 2 answers. Let's do this last one. Just to be different, let's go ahead and multiply through first this time, right? Rather than waiting till the last step, let's do it on the first step. Think about what number you'd want to multiply through by in order to get rid of fractions. If you're thinking of 2, 2's not going to do it, because even though 2 will wipe out the 1/2 here, 9/4 times 2 is just 9/2. You still have a fraction there. So you want what you basically want is the least common multiple of the denominators. Okay, or probably more precisely said, the number that both numbers are divisible by, that's the smallest. Okay, so anyway, I'm not sure I said that right, but I hope you get it. I'm multiplying through by 4 because this is going to give me 4y. 4 times 1/2 is 2x. and 4 times 9/4 is just 9. You see how you have integers now? And then we'll just move the 2x so it's in the right place. We'll subtract 2x from both sides. Negative 2x plus 4y equals 9 is in standard form with integers. Just as good would have been positive 2x minus 4y equals negative 9. Okay, again, you will need graph paper for this, so download that from my website if you need some, and help yourself. If we're back in class soon, you can help yourself with the graph paper in the back of my room, but otherwise you'll need to print it. Thank you.